All right, what I'd like to do today is next week, you people have been really good. Why don't you take next Wednesday and Friday off? You've been nice to me. Because the school's closed on Wednesday and next Friday for Thanksgiving. I'll say it again on Monday, but make sure you all have a happy Thanksgiving. What I'd like to do today because of that is first of all do the review for the next test, and then I'll go over a couple of problems, then we'll do the lab. The lab, if I were to do it, I could knock it out in about 16 minutes. You're going to take about an hour, 45 minutes to an hour, but it's a quick lab, and I'm videotaping today because the fact that I think you'd like, if you want, go back and look at the review. If you know anybody wanting to take this course next semester, tell them to sign up quick, because I think I only have, out of 48 seats, I'm doing a double section, only 6 openings left. I guess the word got out, I know what I'm doing, maybe I don't know what I'm doing. All right, a couple important things. You should have gotten an email with the following, and that is test number 4. Test number 4 will cover acids, bases, and organic chemistry. Ethan, could you close the door for me, please, back there? Organic chemistry. The test has 17 problems on 9 pages. There's no multiple choice, but some of the questions are multiple part. And it will have 56 points on acid and base questions and 49 on organic chemistry. Don't forget how soap works. And it has 5 bonus points. And don't forget that, first of all, I posted the important information that I will give you on test number 4. For organic, a lot of that you have to memorize as is part of organic chemistry. And don't forget, coming up soon is the deadline for the extra credit. Therefore, I'd highly recommend that Monday you bring it in, even if it's handwritten at that point, and show it to me. I'll stick around for a little while afterward. And that way I can tell you what's right or wrong, and you can correct it before you hand it in and get your 10 points. And that's that.
I thought you were talking about saying Facebook. I thought she was mocking
All right, let's go through the review. Anything you see on the screen up here will be in Blackboard for you to download at your convenience. And the first thing you should know when it comes to acids and bases, you should know what is an acid, what is a base. An acid is a proton donor. That's the key thing. Notice I have it in red. And what is a base? A base is a proton acceptor. So, what do you follow? Follow the proton. If it's being given up, it's an acid. If it's being accepted, it's a base. Key acids you should know: HCl. I won't ask you to know the name, but you should know if I ask on a test, here's the structure, is it an acid or base? HCl, H2SO4, HNO3. It starts with an H, it's probably going to be an acid in this class. It's not always true, but for this class, yes. Next, bases you should know, sodium hydroxide, potassium hydroxide, and ammonia. And if I ask, like I did on the problem set, acids and bases, which one of these is acids, which one's base, then I threw in a ringer, which one's a salt, and hopefully that won't confuse you. NaCl, please pass the NACL. Oops. Something I don't have up there, so I better put it on the board. And that's the concept of conjugates. Conjugates are species or chemicals that differ by one proton. And if you have an acid plus a base, and by the way, the order I write it, I could have just easily put the base first. There's no convention. Which goes first? That's just my habit. Where I have drawn the line, the two species differ by H plus, therefore they're conjugates. And same thing here, H plus conjugates. And by definition, everything on the right is called the conjugate, and I'll abbreviate. And if this is an acid, its conjugate is the opposite of base. But let's see if I'm telling the truth. Here I have A minus. Does it accept or donate a proton? If you notice, it accepts it to go to here. So this is a conjugate base. And over here, when this goes from here to its conjugate, does it give up a proton or accept? And the answer is Hb plus. To B, it gave up a proton. By the way, if you don't want to follow charges, just count hydrogens. That will work. And this would be a conjugate since it's giving up a proton, donating one, and acid. And that you should know how to do. Now, water is an amazing material, or chemical, a substance, and it can react with itself in an equilibrium. Equilibrium reaction forward and backward are the same. There's a forward and backward reaction, but it's mostly here. There's a small amount of that. And chemists came up with a constant, Kw, after which it was. But anyways, it's equal to the hydronium ion concentration times the hydroxide. That's 1 or 1.0 times 10 to the minus 14. And that turns out to be a very important equation to help you out. Now, I talked about acids. Acids are where the hydroxide, the hydronium ion concentration is greater than the hydroxide. Basic solution is where the hydroxide concentration is greater than the hydronium. It's sometimes called alkaline solution. Where do you think they got the name alkaline batteries? Because it's basic inside. And then finally, neutral solution. Both concentrations, hydroxide, hydronium, are equal to each other. Now, that's hard to figure out, and someone came up, one of these days when I have time on the internet, I'll try and look and see who did. But anyway, someone came up with a concept called the pH scale. And the pH scale is a number from 0 to 14, and by definition is pH equal minus the log of the hydronium concentration, H3O plus. And when you see something in brackets, that means moles per liter. We've learned about concentration. And to make your life easy, don't tell anybody, if H3O concentration plus is 1.0 times 10 to the minus x, and you put it in here, then the pH is x. And this way you don't have to learn how to use a logarithm on your calculator, which I just make your life just a little easier. This will not be on the test, but you should know the pH scale. At 7, it's neutral. Below 7, it's acidic. The lower it is, the more acidic. Above 7, it's basic. The higher it is, the more acidic it is. Basic, I mean, the more basic. And pH in my stomach is 2.0, and yours too, approximately. Do you know why it's acidic, or pH is that low? Because there's an acid present in there, hydrochloric, and I always think of that as one of the miracles of life, that I have cells and you have cells that make hydrochloric acid. Your body makes that chemical. Amazing. Yeah, organic stuff is more complex, but I know that. But HCl, that's depressing. And you should know, as I just mentioned, the lower the pH, the more acidic. This over. Anyways, and the higher, the more basic. I didn't mention this, but it's a logarithmic scale. So every one change in pH is a power of 10 difference in the hydronium ion concentration. That I'll never put on a tester. All right, buffers. Buffers are interesting solutions. They're made up usually of a weak acid and its conjugate base. And the important thing you should know about a buffer is that when you add a small amount of either acid or base, the pH of a buffer doesn't change. It resists change in pH. And we went through that in class. Now, I talked about titrations, and you're going to do a sort of a titration today in lab. Not a true acid-base, but it's still a titration. But for acid-base titrations, at neutralization, moles of acid equal moles of base, and that's equal milliliters of acid times molarity of acid times milliliters of base times molarity. This you'll be given just like the pH before, you'll be given unimportant information. Next, I talked about organic chemistry. Thank you, sir. All right, I'm going to get help from my helper over there. Help me out. How many bonds to carbon, class? Oh, come on, wake up. Let's go. How many bonds to carbon?
4.
Thank you. Remember that if you take organic chemistry, that's always going to be your friend to help do things right. Carbon always has 4 bonds to it. It's called tetrahedral, the shape, and carbon can form chains and rings, and that's important. I have a number of definitions I'd like you to learn for test number 4. First one is hydrocarbon. Hydrocarbon is a molecule with only carbon and hydrogen atoms. I'll slow down for those who copy. By the way, we can't start lab anyways. They ran out of apple juice. He's going out and getting some right now. But I told him we'll be going for a while here. Now, when we talk about hydrocarbons, there's 2 types you should know. First one is a saturated hydrocarbon. And saturated means it's got all the hydrogens you can put in there. That's why it's called saturated. But a saturated hydrocarbon, since a hydrocarbon is a molecule with only carbon and hydrogen atoms, and importantly, all carbon-carbon bonds are single bonds. Next, you should know about unsaturated hydrocarbons. That means it's missing some hydrogens. That's why it's called unsaturated. It's not totally full. You can't put more hydrogens in there. And this is a molecule with only carbon and hydrogen atoms that contain one or more carbon-carbon multiple bonds, and we call those double or triple bonds. Did I tell you, I think I did, the greatest of all organic chemists is Mother Nature. And Mother Nature never created triple bonds. That's something organic chemists do. I didn't mention in class, but triple bonds play an important role in many things. One of them, by putting a triple bond in a cheap molecule, one you can get inexpensively, organic chemists, and now I'm just talking about chemistry and organic chemistry, nothing moral in any way, but able to create a molecule that's used nowadays and has been for many decades as the molecule that does what it needs to be doing in birth control pills. So when you wonder about this stuff, I let well, everyday or other people's everyday life. Now, I talked about functional groups, and functional groups, and I'll never ask on test, what's a functional group? It's a collection of atoms or that have the same makeup or structure, and they react the same way to various reagents. And this is a very important concept to allow organic chemists to use this to make things, which is, for me personally, the most important part. This is organic chemistry. The ink you see is organic chemistry. The paper, my skin, my hair that's left of it is organic chemistry. And how do you find a functional group? Anything that's not carbon or hydrogen or carbon-carbon single bond, that's a functional group. And you'll see Monday when we go through the problem set on organic chemistry, some of the problems for that. Now, when we talk about organic molecules, a key skill you should have is how to draw them. And I'll never ask what's condensed or what's a structure with parentheses. I stay away for introductory classes like this, structures with parentheses. But condensed structures shows how the atoms are connected and does not show carbon, hydrogen, and carbon-carbon single bonds, even though I write them in. Otherwise, my structures tend to go down toward the floor on a whiteboard, which is not perfect. And if I were to ask, put in the hydrogens for this molecule, how do you know what to do? You know there's 4 bonds to carbon, and therefore this carbon has 1 bond from that, and it should have 4, so 4 minus 1 is 3, and it has 3 hydrogens. Next one has 3 bonds, it should have 4, 4 minus 3, math is hard in organic chemistry, and that should be 1, and it does. And similarly, the others, and that's how you do it. And since I should share the fun, for this molecule, why don't you put in the hydrogen? Alright, I think everybody's done. Let's do this. How do you know what to fill in? You know there's 4 bonds to carbon. If I look at the first carbon, how many bonds to it? 1. 4 minus 1 is 3. 3 hydrogens. Same thing here, same thing here, same thing here, same thing here, and same thing there. Now, let's look at this carbon. How many lines or bonds do you see to it? 4. How many bonds to carbon? 4. 4 minus 4 is 0. Therefore, it doesn't have a hydrogen. Let's look at this carbon. Count the lines. 3 lines. How many bonds to that? 3. How many should there be? 4. 4 minus 3. 1 hydrogen. Same thing here. And that's how you do it. And that's a skill you should have. Now, how do you draw organic molecules that are rings, which we call Cyclo Alkanes, which I won't ask on a test? And we draw that by, instead of showing the carbon, we use the line method, and every bend in a line, well, I'm having a good ring drawing day. Now, I have good and bad hair days. I have good and bad ring drawing days. And how many carbons in that ring count the bends? And the answer is 6. It has a name which I don't teach in this class. There's called nomenclature, how you name things, which is very important, and that's called cyclohexane. But I will ask you the following question. How many carbon atoms are in the following molecule? And why don't you do that? All right, let's take a look at this. Anybody need more time? Anybody need more time, don't want to raise their hand? Let's check. All right, every bend in the line is a carbon. So I can go in this ring, 1, 2, 3, 4, 5. That's 5. Here's a carbon, 6. There's another one, 7. Here's the last one, 8. And the answer is 8 carbons if I counted correctly. And the answer is, I think I did. And therefore, that's a skill you should have. Now, there are 2 reactions I asked you to learn, and the beauty of organic chemistry is you have general reactions. And general reaction tells you whenever you have this and react it with this, this is the products you'll get, or the type of functional group you'll get. And the first one is combustion, which happens in your car engine, in your house at home, in your stove, if you have a gas stove. You have a gas water heater in your house, condo, apartment building, and also your heater in your house, condo, and apartment building. I think I covered every abode you could live in. I guess a trailer too, and that probably also has a gas furnace. All right. But in reality, question would be, give the products for the following reaction. And why don't you try that first, and then I'll do it. check on our apple juice. Maybe he's squeezing the apples himself. I was just going to look for you and see if you were squeezing the apples or something. Good news, we've got apple juice so we can do the lab.
Okay, I want to take this one out.
And here's our lab coordinator or manager, Dr. Linder. And he's doing a great job compared to the last one. Well, that's whatever. You're doing a great job. Thank you, guys. Wow, a brand new bottle of apple juice. Things should go well. All right. Question is, what's the organic, or what's the product or products for the following? How do you do that? You look at this and identify it. What do you see? Only carbon-carbon single bonds, carbon, hydrogen, atoms. So this is a saturated hydrocarbon. Reacting with oxygen. You've memorized this general reaction. I'm asking for the chemicals. Heat's important, but that's not a chemical. And the answer here for general, CO2 plus water. And for here, the answer would be also CO2, carbon dioxide, and water. And in organic chemistry, unless we have to, and you don't have to for this class, we don't balance chemical equations. And you're done, and that's how you do it. Now, another reaction I asked you to learn, I only asked two because we don't have that much time, is hydrogenation. And hydrogenation is where you add hydrogen gas, H2, with a catalyst to make it go quickly to a double bond, and you convert a double bond to a single bond. And here's the general reaction. R means anything with carbons, and that also could be a ring. But let's look at the following. Now let you try this one. Give the organic product or products for the following. All right, looks like everybody's done. Let's do this. How do you determine what's the product of this reaction? You look at the molecule and look for what's different. What's not a carbon, what's not hydrogen, what's not a carbon-carbon single bond. And you see something right there? As soon as I look at that molecule, it's flashing at me like blue or red lights, like red lights at a train crossing. And can you hear the bell too? And that's different. What is it? Two lines, double bond. And what am I reacting with? hydrogen, nickel, and the general reaction, you don't have to put the R groups in, H2 and a catalyst, and the catalyst can be nickel, platinum, or palladium. And what happens, you break one of the bonds, it's called a pi bond, but I'll never ask that on a test, and each carbon of the double bond gets a hydrogen. I'm putting dots in there so you know where to focus. Now, here's an important thing about organic chemistry. Except for combustion, the previous reaction, do you break carbon-carbon single bonds? No. So therefore, I have 1, 2, 3, 4, 5 across. I'll have 1, 2, 3, 4, 5 across. On this carbon, I have a carbon. And the only two carbons that are going to change are this one. I break 1 and 2 bonds. I did that. Each one gets a hydrogen. I know to put in the rest of them because I know there are 4 bonds to carbon. Now, you can write it like that, or you can write it like this if you want. Notice it's got a hydrogen here, hydrogen there. 1 plus 1 is 2. So I can do this. Write it clearly. And same thing here. You can do either one is correct on the test. For you, this is easier, it's less work. And did I tell you I'm this close to the person grading the test? Me. So that's acceptable. A fat is, I talked about fats and oils. A fat is a triglyceride that's a solid at room temperature, and an oil is a triglyceride that's a liquid at room temperature. And if you don't believe me, next time you go home, if you have vegetable oil in your house and it's not in your refrigerator, it's going to be a liquid. And if you have made some bacon and left the frying pan out for a while, once it cools down to room temperature, you'll see a solid in there, bacon fat, otherwise known as white or yellow grease. Beef fat is called tallow. Pig's fat is called white grease and yellow grease. I worked for a company and we bought about 2 to 3 million pounds of combination tallow, white grease, yellow grease per week to make chemicals. That was good fun. Remember, everything on the screen is in Blackboard. Well, how lot? My hand's on the screen, it's not. Oh, it's awful humor Friday. I have to cut that out of the tape. Everybody got that down? All right, this is something you should know. How does soap work? There are certain things I'd like you to leave my class knowing. pH is important, and since I'm going to assume all of you wash your hands every once in a while, I think you should know how soap works. And soap, you should know how to do this. All soaps and detergent have a polar head and a non-polar tail. I can have a slide for that. I didn't draw it though. And when you're cleaning up, use water, and that's polar. And the things you're trying to clean off usually are 2 different categories. Water is the most polar substance in the universe, And then there's dirt and grease, which is nonpolar. And the whole piece of the puzzle that makes this all work, and hold on, I gotta go to larger font. Like dissolves like, and like dissolves like tells us that things that are polar are soluble in polar things, things that are nonpolar are soluble in nonpolar things. You try and mix the two together, they're not soluble. So if I were to look at my hand, there's a little piece of dirt. Let me magnify it and draw it onto the board. And now, if I use water, oh no, it didn't come off. But now if I use soap and water, when I rub it and scrub my hands like this, the soap molecules have a nonpolar tail. They look at the dirt, which is nonpolar. They know like dissolves like, and the tail says, oh, you're like me, nonpolar. Let's line up like this. And a lot of them do it. And because of that, it totally surrounds the dirt molecule to form the following, a micelle. It even says, know this on that slide too. And this is called a micelle. It's probably the only one in the suburbs around here, maybe, when I was taking my shower this morning thinking, oh, look at the micelles I'm making. And I did. Now you know Dr. White's an organic chemist. And micelle, which really looks like this, totally surrounded, they cut out a piece so you can see the dirt in the center. When water comes along to a micelle, I've got a water molecule, it looks at that and says, oh, micelle, I'm polar, you're polar, look the outside, you're polar, I know like dissolves like, let's go down the drain together. And lo and behold, that little piece of dirt is no longer on my hand. You should know how to do this. Describe that. Also, you should know, how does a towel work? After you clean your hands with soap and water, they're now wet, and use something else that's organic chemistry, a towel, and towel is made up of cotton and other fibers, some of them, but mostly cotton. And it's oxygen with a hydrogen on carbon. We call that an alcohol, and those can hydrogen bond. What you should know is, how does a towel work? It works by hydrogen bonding to the water, and it pulls it right off your skin, or if you're cleaning a countertop, drying it right off that. Any questions? All right, everybody, it's bonus time. The following reaction labeled W, X, Y, and Z, acid, base, conjugate acid, conjugate base. 1 point each. Have fun. All right, anybody need more time? Let's do it. All right. First of all, you have to identify the conjugates. That will help you with this. Conjugates differ by only a hydrogen, sometimes a cation too. This has got a nitrogen, that's got a nitrogen, they're going to be conjugates. This has a hydrogen and oxygen. This has only hydrogen and oxygens. So these are conjugates. By definition, the right side is always the conjugate. Always. So I can immediately put down this. So that way I know I won't make a mistake. Now, let's look at W. When W goes from W to Y, its conjugate, is it gaining a proton, just count the hydrogen, or losing? Here it has 1, there it has 0. Something that donates or loses H plus is an acid. Next, when KOH, potassium hydroxide, goes from X to Z, does it gain a hydrogen or lose? It has 1 here, 2 over there, actually it's H plus, but it's easier for you to think of as hydrogen, it's gain. What's something that accepts or gains a proton? A base. When we go back the other way, let's start from Y to W, it goes to its conjugate. Here it has no hydrogens, and there it has 1. Actually, it picked up an H plus, but forget about charges. So what's something that accepts a proton? It's a base. It's on this side, so that makes it the conjugate base. And finally, the last one should be the acid, conjugate acid. Well, let's find out. It has 2 hydrogens, and actually water, and it loses H plus. They go to OH minus K plus. Just count 2 to 1. What's something that donates or loses a proton? A base, and that's how you do it. And that's bonus number 1. Are you ready for bonus number 2? Hopefully you are. Any questions on this? Yes?
Why don't you have conjugate acid?
What?
Why don't you have conjugate acid?
Oh, I made a mistake writing. Thank you. Hold on. Bad pen. I made a mistake. That's why I don't. Thank you for catching that. All right. I'm going home. I'm dangerous. I'm mistake prone today. And one more bonus question. Question is, if the hydronium ion concentration is 1.0 times 10 to the minus 5, what is the pH of the solution? And is it acidic, basic, or neutral? Ready, set, go. By the way, John, if you get this, you get sick, don't find me. Now, can one of you go clockwise and the other counterclockwise and get each other dizzy? All right, stop.
Who just lost the leg?
By the power vested in me by the state of Illinois and the sheriff of DuPage County, stop. You know I would have all that authority. I don't. Anyways, all right, everybody done? Because if you're playing around, you must be done. All right, let's look at this. What are we trying to find? What are we given? What do you have in important information? pH equals minus the log of the hydronium ion concentration, and that's equal to minus the log of 1.0 times 10 to the minus fifth. And therefore, if we look at this, Dr. White's gift, if the hydronium, which it is 1.0 times 10 to the minus x, then minus the log of that is x. In this case, x is 5, and therefore the pH is 5. Next question, is it acidic, basic, or neutral? And if you look at it, if the pH is less than 7, it's acidic. If it's at 7, it's neutral. This I won't give you, you've got to learn that yourself. And if it's above 7, it's basic. This is below 7. I hope you know your numbers 0 to 14, which is larger and smaller than 7. And therefore, the answer here is this is acidic. Any questions on anything that might be on test number 4?
Can you give us an example of that, and that would be a two-step problem?
What?
Can you give us an example of that, that would be a two-step problem?
All right. By popular demand, it's Request Friday. There you go. That was quick. There's your two-step. If the hydroxide ion concentration, oh wait, just so you don't feel cheated. There you go. If the hydroxide ion concentration is this, what is the pH of the solution? And you'll also be given this. Where's this? I'll write it on the top of the board. That will help you out. There you go. And I'll leave this up too. There you go. There's your two-step. Done. You want to do it on the board? I'm just kidding. Did I tell you, I think I might have, years ago, I used to make students go to the board, especially when we were in the other old building, because in the classroom we had boards on the side and the front, until I realized students would rather pull their teeth out with pliers than go to a board. And I figured, why am I making my students so miserable? So I stopped that. All right, looks like everybody's done. Let's do this. Question is, somebody still need more time? Twice? Oh, by the way, relax. The lab today, you'll all be out of here by 11 o'clock, which is still way early. All right. What are we trying to find? pH? What are we given? Because of that, we can't find the pH because we need the hydronium ion concentration, but you're given this, so you need to do two steps. know that. We want to solve for hydronium, so I want to get rid of the hydroxide. I'll divide by that. Whatever I do to one side, I have to do to the other, so I'm going to do that. Anything divided by itself becomes number 1, cancels out. Now we have this. For everybody to catch up. Next time you look at a bottle of ketchup, the pH is less than 7 because it's acidic. Same thing with mustard, relish, and your pickle jar. Anyways, now I'll put in the hydronium ion concentration. You need a calculator. Dr. White doesn't, because I grew up with a slide rule, and I can do this in my head. And that's the hydronium. Now I'm running out of room, so I'm going to have to write over here. Hopefully you copy down the problem. Now we solve for the pH. pH is minus the log of the hydronium ion concentration, which you will be given. In this case, we just solve for it, so we know it's minus the log of 1.0 times 10 to the minus 10. My gift to you is if this is 1.0 times 10 to the minus x, the pH is x. X in this case is 10. Is that acidic, basic, or neutral? And the answer is it's basic because it's greater than 7. And there's your request. All right. With that, if you have any other questions, listen up. After lab today, I'm going to stick around as long as you need me until they can kick us out of the room, which is 10 to 12, which we'll have plenty of time. Ask questions. Also, if you have your extra credit, you want me to look at that, ask questions. Remember, the extra credit is your own project. You can't copy anybody else's. I usually catch it. That's happened about 5 or 6 times over the years, so please don't. All right. Handed out the lab.